next what we're doing is countermeasures for race conditions. If you've not seen what race conditions are, I have linked it to the in the description box. You can check what race conditions are and how it works, basically before obviously learning the countermeasures for it. So like we discussed in the previous, there is a window within which you're checking and you're actually using or opening or accessing the file, where there is no permission check of the particular file that you want to target. So the first countermeasure relates to this window. What you're doing is you're eliminating this window itself. How? By performing atomic operations. In this case, what happens is your open filing, that's ocreate what you're doing is you are checking for the permission and accessing it at this and opening the file in the same operation. So there is no lines of code where you can actually race in between and then target the files. Atomic operations are one of the most effective ways to do it, but the problem is that not all processes or all functions can be done atomically, because of which there are other countermeasures also that are required. So what it does is basically eliminates the window, and then open file will not exist, and then you cannot really follow the symbolic links. That's what we were discussed about. Second, what you could do is you could repeat check and use, like instead of just how you're checking it once and then using it after some time. Instead of doing that, you like check again here and then again check here before using, and then again check here before using. So this is not a very great method, but what it does is it makes it more difficult to actually win the race, because you have like the window is basically reducing. So that is your second great way. Third is something I already discussed before. That is what Unix basically does. In StickySymlinks, what happens is you can actually turn on the StickySymlink if you want it or not. Like if you're attacking it, then obviously you will disable it. What it does is it prevents the program that you're running from following a particular symlink in a world writable sticky directory. So what you do is sysctl and equal to 0 or anything like that. So the sticky base is actually set. The files inside the directory can be renamed or deleted. Okay. Now there are three things in this particular set that you bother about. First is the file's owner. Second is the directory's owner. And third is your root user. Okay, the sticky bit is not set. Okay, else if the sticky bit is not set, what happens is only the user with a write and with your write and execution permissions for the directory can rename or delete files regardless of who owns it. Okay, maybe the owner is X, maybe owning it, but if you are not owning the directory, then you can't really edit it or delete or rename the files regardless of who the owner is. Now when this sysctl is actually enabled, okay, the symlink can only be followed when the symlink owner equal to the follower or is equal to the directory owner. So now what it's doing is, like I said, in sysctl when it's disabled, Okay, the directory owner has to be checked. Okay, but in that case what happens is uh, you're not really countering this entire measure. But when it is enabled, okay, the only person who can enable Symlinks is if the check is such that if the Symlink owner is either the follower or the directory owner himself, only then the Symlinks get followed, and otherwise it is not following the Symlink, and the attack basically is not successful anymore. So if you have, say, root, okay, that is your EUID, and root again, which is your temp owned by root, and you have seed, which is a symlink that is not created by root. Okay, simply the access will get denied to follow the symlink, and you're out. So when the symlink is not created by root, and if you're trying to access root files, then it will automatically get denied and you're done. Okay, now the fourth and the is your least privilege, which is basically, I think, a security policy all over the world. Okay, now here what you're doing is you basically, the privilege programs are writing to file that do not require privilege. Correct? So in that case, you basically completely shut down the privilege of the file itself. That is doing the edits, like the writing file. So unless you need that file to really do something at that particular time, you do not give him that access. So you set EUID to real UID. Okay, F equal to open. So access of the real user here is checked, not root, because this is effective user ID. Okay, and then again you set UID to effective UID. Okay, when you don't need it. So this is you giving it least privilege now. Okay, when it needed, it is getting the, sorry, you're giving it the least privilege now. When you need it, you can set it and then set it back to basically the least privileges possible. So these are basically the 4 ways you can counter these conditions.